All right, so let's take a look at the different types of tests that QA engineers consider, right? So oftentimes it's helpful to think of the application or whatever feature that we are testing using the analogy of a box. Right? This is very similar to what we considered way back when we introduced black box testings and white box testing to talk about unit tests and structural testing. Yes. So similarly, the QA folks use similar jargon, similar meanings to what we use, but there's some differences that we might need to point out, right? So for black box testing is somewhat the same definitions that we use, right? We are testing a feature or some product, and we don't have visibility into the implementation of that of whatever it is that we're testing, right? We only have access to perhaps the user interface and the fields and buttons and mouse and keyboard, and that's the only way that we can interact. We have absolutely no idea or care on whether you're using linked lists or for loops, or this is a desktop application, or this is a remote application hosted on some server. We don't care, right? We don't care about the implementation. We only care about the facade, right? That the application provides. Now, gray box testing is a semi-transparent, meaning we do know a couple of things about the implementation. We might know that this is a remote application, that you have some RESTful services that you need to hit. We know that there might be some lag between the query and the response from the server. We might have some knowledge on the architecture of the application. We might know that it's a single-page application, that we might know that user interface might take a while to render, right? That waiting for responses to come back from the server, and that you might have some spinners in there. Right? And that might inform the QA engineer on what kind of tests that they should run on your application. You know, having some understanding on the architecture and the implementation choices for the application. Right? And then there's white box testing that very much like we have covered earlier. There's a transparent access or understanding on the algorithms that were used to implement the application. We might know that there's certain branches, certain for loops, certain switch cases, and that informs certain edge cases that we might have not known, right? You know, very much like we design our unit tests from our structural testing, in informing our unit tests. Similarly, the test engineer, the QA engineer, might also be informed that they might want to try out different edge cases in their input fields, right? Now, these box types of testing have different purposes. They're performed by different folks, right, and are associated to different types of testing that folks might accomplish on the application. For instance, the black box testing, there are different types of testing that fall in this category. Right? For instance, manual testing and automated testing both are specific examples of black box testing. Right? So, for instance, manual testing is literally the QA engineer bringing up the application, interacting with a keyboard, mouse, and certain pages they navigate, and they enter certain information manually, and then they compare it against some expected behavior. They might also automate some of these manual tests and say, oh, well, I don't want to do this 1,000 times, and write scripts that exercise the same thing that we would normally do manually, but now it can be done repeatedly, indefinitely, right? It's still a black box testing since it's exercising only the facade of the application. Typically, these types of testing, the manual and the automated testings, are typically performed by a QA engineer exclusively. Right? We might, as developers, we might do it as well, but more commonly, it is the QA engineer's responsibility to do the manual testing, do some of the automated testing, and the purpose is to verify that the functionality is on par on what the specified functionality is, right? So we compare the actual functionality with the expected functionality, and we report on any discrepancies between the actual and the expected. But also, it's an opportunity for a QA engineer to validate or to express certain concerns on some of the implementation choices, maybe some of the verbiage that we're using, maybe on some of the choices that we made on that might make the application a little bit less clear. Here you have an input field, but there's no label, there's no placeholder, there's no tooltip. What do you want me to type in here? So they might have some suggestions on how the quality of the UI might be improved, and they might suggest some usability defects, right? On some improvements, some enhancements. So again, these are mostly the realm of the QA engineering exclusively. For the gray box testing, usually it entails also exercising the UI, exercising one of the layers, but taking a look at the other layers as well, right? Where I might exercise clicking on a particular button, but then I would like to see, if I click on this button, how was that reflected on the database? Was a record actually removed, or was a record actually inserted, or was it actually updated, right? So now no, you're not just looking at just one layer. You're looking at the interaction between multiple layers, right? Or it might be that if I click this button, I might open up the console and verify that there's a response coming back from the server, and that the JSON file, the JSON that comes back has a particular format, and that it has a particular ID or has something that I would expect. So this goes a little further, right? And not just at the UI layer, but considering the multiple layers, right? Now, these types of tests, we often refer to them as integration tests. How are the various layers talking to one another? How are they affecting each other? How the DOM might be reflected in the JSON, reflected on some record in some database. Oftentimes, these types of tests are the responsibility of both the QA engineer and the developer. Perhaps using different technologies, right? Where the QA engineer might use either just a browser and just the console and looking at the database, or they might be using maybe Selenium to interact and automate the interaction with the browser. The developer might be using other tools such as Karma or Jest, right? Where they invoke these APIs and then they can automate the check of these JSON responses. Nevertheless, it's very useful and responsibility of both QA engineers and developers. The white box testing is usually based on intimate knowledge of the algorithms, right, and the processes of implemented in code. Right, so meaning we have access and we care about the algorithm that was implemented, with our loops and if statements and whatnot, and which informs the edge cases that we might include and implement some better unit tests. Usually, this is the realm of the developer. Developers really are the ones who care more about this, who have an initial set of unit tests based on an initial read of the use cases, of the requirements, and then they might add structural tests, right? Structural tests to look at whether they have coverage, and might inform that they might improve their unit tests to have a better coverage, right? So again, this is mostly for the developer. So here's an example. Let's take an example of the following set of use cases of interacting with a shopping cart. Right. So as we interact with a shopping cart, we might have we could implement the following actions, such as being able to add an item to a shopping cart or remove an item from a shopping cart. Also, and want to verify whether the shopping cart quantity has gone up. Also, we want to verify that the total cost or the total price of the cart has been calculated correctly, depending on the quantity and the items that were added. So those are kinds of tests that we want to implement. Now, depending on the type of testing, and also depending on based on that type, who's implementing this, right? We might take different approaches at implementing these tests. If it's a white box testing, typically these are unit tests that developers implement. Maybe even coverage, a structural test that might give a measure of the coverage of those tests. It might inform me that I might need to add additional unit tests for different input fields that would increase the coverage. So as a developer, having intimate knowledge on the implementation, I might implement functions that performs the increase operation, the decrease operation, and the calculation of the total value of the cart. And then I might write a test that exercises that function, and then asserts compares what the expected value is against what the actual value is. Right. So typically this is implemented by us developers, either using JUnit or Jest or any of those techniques that we've been talking about for the last couple of weeks. Yes. For the gray box testing, these are tests that both the developer and the QA engineer are interested in. Right? They might write a Jest test or a test unit test, a unit test that might use Mockito, or they might use that would exercise the API, would actually go out to a database and fetch data and see whether it's working, and implement integration tests, right? Validating not only the controller but also the services and any additional repositories and even database access. As a QA engineer, I too would also implement my integration tests that would exercise perhaps Selenium, clicking certain buttons, and then looking at the response from Selenium, right, and verifying that the response is correct, and assert that the items were increased correctly or decreased, and verify the response was successful. So this is mostly again for integration tests that are the realm and the interest of both QA engineers and developers. And then there's black box testing, where mostly is the interest of QA engineers, although we too might want to implement some of this as well as developers, whereas they might be testing exclusively what the UI is responding, right? How the UI is responding to events, irrespective of the actual implementation of any RESTful services, any complex computation on the server side. We just want to know that if we click on this item and we navigate to the cart, we can verify that the quantity has gone up by 1 or whatever, or that the value has calculated correctly. So here's an example of just using jQuery and simulating a click and extracting some value from the cart and validating it against some expected value. Okay. Manual test is one of the ways that QA engineers test our applications, and typically what they would do is that they would replicate the actions that would be performed by an actual user. They would be responsible for identifying what all the scenarios that a user would use to interact with the application, and they would keep track of this in a test plan of all the various scenarios that are going to be considered. Considering what are the typical use cases that are taken by most users. Out of all the users, what are 80% of those users visiting? What are the 80% of the folks actually doing? Right? and trying to categorize which ones are very typical, the typical ones, and the rare ones, so that we can better focus on the typical ones. Right? So here's an example of a manual test as we are interacting with a flight agency application where folks can search for a flight, or they can buy a flight, they can check a flight status, and these would be perhaps various features that the QA engineer would need to test and a developer engineer would need to implement. Right? They would need to create in their test plan, they would need to list that they can search for a flight, they can buy a flight, they can check the status of a flight. So early on in the design phase, the QA engineer and the developer might meet, right? And they would run through, brainstorm what are the different scenarios, and identify what are all the happy paths and what are the sad paths and what are all the edge case scenarios they need to consider, and then keep track of this long list of all the different scenarios. What with a short title for the different scenarios. What are the expected results? Perhaps the steps to perform the test. Any outcome from the last time that these tests were executed, that they were passing last time we ran them, or that they failed. So keep track of some statistics on these tests. Also the data that we intend to be using for the tests. If we are traveling from one part of the country to another, we might choose San Francisco to LA. The dates that they were departing. We might focus on some of the more common, aspects of searching for a one-way flight or a round-trip flight, and then maybe not consider as much the ones that are more rare. That you ask us for an invalid route that it's impossible to travel, or maybe a route that is not in operation anymore, or that you ask us for something that we want to travel from the same origin and the same destination. So we would capture all the different test data that we could be using in the test plan. At some point, we want to automate our tests, that we can repeatedly and consistently execute these tests, so that we can take into account the multiple frameworks, multiple environments, multiple browsers, multiple versions of those browsers, multiple operating systems. Because if we try to do this manually, we'll need to face a combinatorial explosion that there's no way that we would be finished on time, right? So we need to be able to multiply our particular knowledge of manually testing, maybe recording our tests of clicking and dragging, and then taking those recordings and as scripts that can then be executed through Selenium, and so that can automate running hundreds of tests, right, against a different combination of OS, operating system, browsers, and vendors, and versions of those. Ideally, we would be able to integrate these tests with the rest of the software development lifecycle, even with continuous integration, so that if something does go wrong in the in the testing of the front end, that the build would stop, right? That we identify something wrong, it would not promote the build to a release, right? Also, because these tools oftentimes encompass instantiating an actual application or browser, or these might be fairly prohibitive to run these automated tests. Oftentimes, these tests are slow, since usually these applications were written to interact with human beings. Right? They might have a lag time of half a second, which is okay for a human being, but it's an eternity for an automation, right? Where having to take into account the fact that some user interfaces take time to render. You might have spinners that you have to wait, right? That the data is actually coming back from the server. So you have to take into account all these factors that would be okay if you were testing this manually, but if you're testing them, if you're doing this hundreds or thousands of these tests, right? These might take an all night, right? And that which might be okay if you run these over the weekend, or you run them off hours. But what needs to be considered is that oftentimes you would not automate all these tests, right? You probably just automate a subset of the tests, perhaps the tests that are most important, right? The ones that certainly want to make sure that these are up and running and that these never fail, and perhaps relegate the ones that are more obscure or the ones that are least the least common workflows, right? Leave those to manual tests, right? That can very quickly do a smoke test, check to see they're still working, and they're low impact, low priority ones that we can quickly do it manually. Yeah. So here's an example of the 5 scenarios we have identified. We have chosen that these 3 are critical. That we certainly want to be able to run them across all browsers, across all operating systems, across many different combinations of the framework, and make sure that they all work correctly, right? And that it would take quite a while to do this manually, and it might take a while also to run them automated, but they are critical, and certainly we're willing to pay that price. So these automation scripts usually are dependent on the specific framework that you've chosen, right? We're using the framework of a web application, but certainly there's tools to automate tests for any framework, right? Whether it's a standalone application running on your laptop where it's only one user, one application, right? Or whether this is a mobile application, right? There's tools to test everything, anything that you can think of, and each framework will have its own set of tools, will have its own set of languages that are supported, different operating systems that are supported, and whatnot, right? And you'll have to learn that specific set of tools for whatever framework. We're going to be focusing on web, but if we're using some other framework, obviously you'll have to learn that particular framework for testing that particular framework. Whatever framework you do choose, typically there will be some language by which you can write down. You can declare tests. You can write down the different steps to follow and interact with whatever user interface you're using. Whether it's a desktop or is a web application, there'd be some way that you can automate the interaction of that user interface. So here's 3 of these scenarios that we've decided to automate and listed here. Searching for one-way flight, round trip, or same origin and destination. And if we just focus on one of them, usually the framework or the language will give you a mechanism to be able to interact with particular fields, particular buttons, scroll bars, text areas. So in this particular case, we are able to type into particular input fields, such as the origin input field or the destination input field or the date of departure field. We can fill in data in there, and then we can kick off a search, and presumably this will communicate with some remote server and come back, and then we can check to see whether the user interface changed correctly, that there are 10 flights that were found and that meet our particular criteria. There might be some synchronization here, since this typically will be an asynchronous call to some remote server, and we need to synchronize both flights. We'll talk about that when we back on Friday on how is it that we synchronize middle tier and front end tests. There's also integration testing, as I mentioned earlier, which is a type of gray box testing, where it doesn't focus on just one layer, but instead is more interested on looking at how each layer interacts with the next layer, right? That if I jiggle this particular layer, how does that propagate through the rest of the layers? In gray box testing, we would automate the interaction. In our particular case, because it's web, we would be interacting with the DOM and seeing how that propagates across the middle tier. The middle tier perhaps responding with some JSON object, or going down to the data layer and inserting or updating or deleting a particular row in a table. And so this certainly is it's faster to implement this, since we're talking about lags between machines talking to one another, which usually are an order of magnitude faster than us interacting with keystrokes and mouse. So oftentimes what we might decide to do is go back to here and say, we're going to focus on these scenarios, and we're going to automate those, right? These over here we might want to implement manually. We'll do these manually, and then yet some other subset we might automate, but we'll automate using integration testing, right? Because we know those are much faster. You're just going, hitting a server, comes back. I can verify the JSON, and I'm done, right? I'm not waiting for the spinner to go away and the rendering of the DOM or React doing its thing or whatnot, right? I can usually the lower priority ones I can also automate by using integration testing, right? By doing a quick hit the server, respond, checking to see that the data is correct, and that might be enough, right? We might decide that that's enough as for automated tests. Yeah. So integration testing might actually exercise the API, go fetch some data and post it to a remote server, come back with a response, and then we would compare against some expected value. Other testings that are important are whether the application over time degrades, right? Whether we have memory leaks, whether it no longer can ask for more connections to the database. How does it perform in the long run? Does it scale well, right? Does it work well with one user, with 10 users, with 100 users? How well does it work with thousands of users, right? So we would like to be able to know that early on, right, to make sure that our application is scalable. Usually, if we've done a good job at having a stateless application, usually those applications scale much better, since they don't have to maintain any session data for any particular user. Whereas if we have a stateful application, usually those have a much bigger memory footprint. They tend to be more leaky, right? They tend to keep track of objects in memory longer, and so they might grow over time and are not as scalable. So these are three types of performance testing. They all are black box types of black box testing. Right, so load testing, endurance testing, and stress testing. These are all types of black box testing, meaning we are exercising the UI. We're exercising this behavior. We're testing this particular behavior, regardless of what's inside of the implementation. We don't really care that internally, you're using linked lists or you're using whatever internally, right? We just want to exercise this behavior and then check the response. Check to see how long does it take to respond, what the memory looks like, what the CPU footprint looks like, what the database connections look like, right, over time, right? But without really caring what's inside of it, right? So for load testing, what we're looking for is to measure, try to identify what is the maximum capacity of this application, right? We want to exercise it with a number of users and see where we still start seeing degrading of the application. Endurance testing is similar to load testing, but we apply load testing for a prolonged amount of time, right? And not only do we care about the maximum performance, but we want to see over time if there's any memory leaks, if there's any connections that are are not being released, right? That we're keeping some connections open, and the database at some point runs out of connections, right? And we can only determine this by running applications for a long period of time, right? And see how they perform in the long run. And then you have stress testing which is somewhat similar to the other ones, but we want to see, what would happen if the application is, executing and we start perhaps removing some of the resources, right? Maybe we reduce the amount of memory, maybe we reduce the amount of sockets, maybe we remove the number of servers that are available, right? And we throttle down the speed of the network. Right, and we want to see how the application behaves, right? If we see that it crashes, or does it, how does it adapt, right, at different varying degrees of resources that are allocated to the application. Now, graphically, we can keep track of how the application, the time that it takes applications to respond. Based on the number of virtual users, right? Typically, we'd automate or simulate, thousands of users hitting the application at the same time, and then measure, how long does the response take, right? At low load, we measure, how long does it take us for sending an HTTP post, and how long does it take for it to come back. And then we try with 10 users, the same thing. And then we measure how long does it take to come back. And then 1,000 users, and then 10,000 users, and see, what is the load that breaks the application, what is the actual maximum, right? We monitor the total round trip of a query. For endurance testing, again, it's the same thing. It's also oftentimes referred to as a SOAP testing. And we do the same thing as load testing, but for a prolonged amount of time, and see if we can identify any memory leaks or connection leaks. And for stress testing, right, we progressively increase the amount of load, at the same time removing some of the resources that are allocated to the infrastructure. So if this is a round robin, multiple machines in the same cluster that can take up the load amongst each other, maybe we take down one of the machines, right? Maybe we take down 2 machines and see how it behaves over time, right? Or we throttle down some of the network, right, and see how well does it adapt. And basically, the idea is that we want to make applications more resilient, and we want to measure the capability of scaling and recovering and their stability. The other type of testing that's also very important is the security testing. We want to make sure that folks are not that the right folks have access to the right information, right? That we're not leaking private or sensitive information to folks that should not have that information, right? And acknowledging that we are certainly going to be attacked at some point with malicious folks, either trying to guess at our password or pose as someone else. Or they're trying to perhaps deny services by sending thousands of bogus requests, or somehow misplacing or making some data that should have been private is being made public. Some of the types of attacks include SQL injection, where we send SQL snippets as part of input fields, and hope for those to be concatenated against other fields and executed literally on the database and exposing some of the data in the back end. Cross-site scripting and password attacks. SQL injection is just a technique where hackers might include snippets of a SQL query that if we don't remove some of the malicious characters in there, it might be interpreted as a legitimate query, right? And just typing out the input field, that if they make it executed at on the database, they might return some information that might be privileged, right? So we always have to make sure that we sanitize our inputs, right? That we don't let certain parentheses or quotes or semicolons or certain malicious characters through to the remote server. Denial of service is a technique that hackers might use to bombard applications with bogus, requests, right? That put the server make the server busy, responding to these bogus requests and starving the server from being able to resolve or to service legitimate requests coming from legitimate folks. And usually we have tools that can identify these vulnerabilities and identify which are bogus and which are legitimate, right? And ignoring the bogus ones. Or we have servers that might on standby that we can redirect these bogus queries to, and without starving the legitimate requests. And now GitHub also has a lot of tools that automatically parse your code and identify some of these vulnerabilities, and GitHub will alert you, right, and point out some of these vulnerabilities, suggesting that you fix these before making this into production.